In this video, we're going to work on creating equations of trig waves based on a graph or corresponding information about a function. So far, we've been given a trig function and used that function to calculate the amplitude, period, phase shift, and midline, and then sketch the graph. Recall the general equation for the sine and cosine functions. We have y is equal to a times sine of bx plus c plus d, and y is equal to a times cos of bx plus c plus d. So what will happen here is that we'll have a graph or given information about a function, such as the amplitude, the period, phase shift, and midline, and using that information, we will determine the values of a, b, and c, and then we know the function. If we're told the amplitude, that means that we know the absolute value of a and can determine the value of a. Therefore, a is equal to the amplitude. If we know the period of a function, we know the period is equal to 2 pi divided by b. Therefore, if we know the period, we can calculate the value of b by using the formula 2 pi divided by the period. If our period is given to us in degrees, we would calculate b as being equal to 360 degrees divided by the period. In previous videos, we looked at how we calculate the phase shift. Phase shift is equal to negative c divided by b. Therefore, if we already have calculated a and b, we can find the value of c by multiplying the phase shift by negative b. And all of these equations for a, b, and c are found by rearranging our equations for the amplitude, period, and phase shift respectively. And lastly, if we're told that there's a midline other than the x-axis, then the midline is equal to our d value in the general equation. So you can either memorize these formulas or derive them from the equations for the amplitude, period, and phase shift. And I always recommend keeping a little study sheet with these formulas handy as you become accustomed to using them. It's good to practice with a study sheet, and you can also use that for your digital homework and tests. In this first example, we want to determine a possible equation of a sine wave having an amplitude of 4, period of pi over 3, and a phase shift of pi divided by 24. Let's start with the first given piece of information. We know that the amplitude is equal to 4. This means that a is equal to 4. It's worth mentioning here that you could also use an a value of negative 4, since the amplitude of a value of a that's negative is just the positive value. We're also given that the period is pi over 3. Using our period, we can calculate the b value. Recall b is equal to 2 pi divided by our period, which is equal to 2 pi divided by pi over 3, and we can calculate b inverting and multiplying. So we're going to multiply by 3 over pi. When we do so, our pi's cancel out, and we end up getting a value of 6 for b. And the last piece of information we have is that the phase shift is equal to pi over 24. Using the phase shift, we can calculate c. So c is equal to negative b times pi divided by 24. b is the value that we calculated in the previous step. So we have negative 6 times pi over 24, which reduces to negative pi over 4. In this question, there's no mention of a vertical shift. Therefore, the midline of this trig function remains at the x-axis, and d is equal to 0. So now we've calculated the a, b, c, and d values of our trig function. We're also told that we're looking for a sine wave, so we need to make sure we express it in terms of sine. And what we'll do next is write our general equation. Therefore, y is equal to 4 times sine of 6x minus pi over 4 plus 0. And we don't need to show the plus 0. The reason why the question asks for determine a possible equation is that you would also receive full marks if you were to have minus 4 times sine of 6x minus pi over 4. And that would be a reflection in the x-axis of the equation we have shown here. But both of them would be correct and receive full marks. In this example, we want to express the equation of the graph below as a cosine function. We know that we want a cosine function. We need to identify some key attributes based on the graph. Whereas in the last question, we were told the amplitude, period, and phase shift and used those values to determine the equation of the trig function. In this example, we have a graph and we need to determine or read the amplitude, period, and phase shift from the graph. We know that a cosine function will begin with a peak or a maximum, so we can identify the starting point and the stop point of one single period of our cosine function. The midline of our cosine function is our x-axis, therefore d is equal to 0. There's no midline shift. And we can see that the maximum and minimum value of this curve are 3 and -3. Therefore, the amplitude is 3. And this means that we have an a value of 3 as well. Based on our start and stop values that we identified, we can determine what the period is of this graph. So we have a start and a stop, and the period is the distance from the start to the stop. We can take the scale on the x-axis and determine what each grid point represents. So if we go from 0 to pi and divide that in half, we get pi over 2. And each of those is divided into thirds. So we get pi over 6 and 2 pi over 6, which is pi over 3. 3 pi over 6, which reduces to pi over 2. 4 pi over 6, which reduces to 2 pi over 3. And 5 pi over 6. In the negative direction, negative part of the x-axis, we have negative pi over 6 as our starting point. So our period goes from negative pi over 6 up until 5 pi over 6. To calculate the period, you take the stop value and subtract the start value from it to calculate that length. So that works out to 5 pi over 6 minus negative pi over 6. And that simplifies 5 pi over 6 plus pi over 6, or 6 pi over 6. And the period works out to be pi. With our home graph of a cosine function, we would have expected to have our starting point at 0, 3, because the amplitude is 3. But the entire graph has been shifted to the left by pi over 6 units. So our phase shift is negative pi over 6. Now, based on our period and phase shift, we can determine the constants b and c in our general equation. Remember, the equation that we are working towards is y is equal to a cos of bx plus c plus d. And what we're trying to find or determine is the coefficients or constants a, b, c, and d. Given that our period is pi, we can calculate the value of b, b is equal to 2 pi divided by the period, which is 2 pi divided by pi, and that reduces to 2. With the phase shift, we use the formula to find c. Remember, c also relies on b. You get negative b times your phase shift. So negative 2 times negative pi over 6, which reduces to pi over 3. Therefore, we can express our final equation, y is equal to 3 times cos of 2x plus pi over 3. And we know our d value is equal to 0 because the midline of the function is the x-axis. So now we've seen how to calculate or determine the equation of a function if we're given the amplitude, period, and phase shift, or if we have a graph to determine the amplitude, period, and phase shift. Now we have a practice example. Make sure you pause your video and give this a try and verify your solution afterwards. So we want to write the equation of a sine wave having an amplitude of 2, a period of 4 pi, and a phase shift of negative pi over 12 radians. So we want to find the values of a, b, and c such that we have the equation y is equal to a sine of bx plus c plus d. Remember here it mentions nothing about a midline shift, therefore we can assume that d is equal to 0. Technically, for this, you could have any midline value given, and it would be a valid equation. It would satisfy each of the other constraints. Let's write down everything we know and then calculate the constants. Given that our amplitude is 2, this means that our a value is equal to 2. Since our period is 4 pi, we can calculate b as being 2 pi over our period, 2 pi over 4 pi, which reduces to 1/2. And lastly, our phase shift is negative pi over 12. So c is equal to negative b multiplied by the phase shift, which is, you want to make sure that you've spent the time to get your b value correct, because it will carry forward as we calculate c. And our phase shift is negative pi over 12. And this reduces to positive pi over 24. Therefore, a possible equation for this sine wave is y is equal to 2 times sine of 1/2 x plus pi over 24. It's worth noting that there are various sine functions that would share these same attributes. So it would have an amplitude of 2, period of 4 pi, and phase shift of negative pi over 12. If you gave another function, so for example, if your a value is negative 2 instead of positive 2, it would also satisfy the criteria, and that would be a correct answer. There's also other ones where you have a different d value, so you're shifting that equation up or down with different midline equations. And you can also phase shift more than one period, and it would give you an equation that satisfies the same attributes. So make sure that you can check your answer as well. You can graph it in Desmos and check if it has an amplitude of 2, a period of 4 pi, and a phase shift of negative pi over 12. Now that's the end of the Module 2 notes and videos. In Module 3, we'll be looking at solving trig equations. Make sure you reach out to your professor if you have any questions about any of the content in any of these videos or in the notes. We're happy to help. Take care.